Let's go and find the two real irrational solutions of this quadratic equation using the quadratic formula. Now, the first thing I always tell students is make sure that you have your quadratic in standard form set equal to 0, just like something like this. So if you have x's or numbers on both sides, whatever else, get everything over to the same side, set it equal to 0. Then the next thing what I want you to do is identify your a, b, and c. A represents the coefficient of your quadratic term, b represents the coefficient of your linear term, and c represents your constant. Okay, so now you can see your b and c, I just lost my cup, but b and c are going to be the exact same values. That does not matter at all. And you'll see in the formula, they obviously have different processes or different values, and that's not really going to impact things. But once we have it in standard form, set equals 0, now we've identified our a, b, and c. Now the next thing is to make sure we know our quadratic formula. I have a love-hate relationship with the quadratic formula. It's very, very important. When I taught, calculus and pre-calculus, sometimes students would be like, I forgot the quadratic formula. I'm like, you didn't do enough practice. I don't like the quadratic formula song. I don't like testing my students on memorizing it. I don't think you need to memorize it. But the reason why I know the quadratic formula so well is because I have done so many problems using the quadratic formula. So my point or my thought process, memorizing formulas or what you should be able to do, like if you don't have this formula memorized, you have not done the quadratic formula enough. Do more practice problems. I think it can only be beneficial for you to, one, eliminate your mistakes, and also to remember what the formula is, especially in times when you need it. And that's where the quadratic formula, I think, becomes most crucial, is when you're doing problems and it's not explicitly said, use the quadratic formula. Like that's what I started this video on. We're going to solve this by using the quadratic formula. But where it really comes in handy is when you have a quadratic set equal to 0, you're not told to use the quadratic formula, but you can use it as a tool to help you out. So do enough practice problems and you will get this ingrained in your memory, and because you'll have that muscle memory. And so that's what I would expect for you to do rather than trying to memorize to remember this gobbledygook of something you're never going to use in real life, right? All right, so we've identified our a, b, and c. Now all simply need to do is go ahead and plug in our values into here. I always like to plug things in with parentheses. That just reminds me as a student that I am replacing a variable with a value. And just remember, guys, whenever you have a negative, we can always assume that is a -1 in there, okay? So a lot of times that gets students confused here. Why did you get a -1? Well, again, it's a negative, right? -1 in front. And I got that thought in my brain. I'm like, oh, I wanted to start talking about it. But then I almost forgot. You got to make sure you include the denominator. And make sure when you include the denominator, this 2 times a is divided by everything. So that's opposite of b as well as the square root of b squared minus 4 times a times c. So now what we simply need to do is just go ahead and simplify. Now what I usually like to do is actually do the discriminant first. So rather than actually doing all of this and rewriting everything, it becomes a lot and it can become, cumbersome to do it, especially if you're taking like a test or a quiz and time is not on your side. So a lot of times what I like to do is just take whatever's under my radical, this b squared minus 4 times a times c, and do that separately. Right? So I already have the values up here. And what's important about the discriminant is this is also going to tell us everything about what type of solutions we're going to have for our quadratic. Now, I already said there's 2 real irrational solutions. This is going to explain that. Okay, so what we have here is 45. Now 45 is positive, so therefore we know we can take the square root of it and we're going to get real solutions. However, we can't take the square root of 45 and get an integer. So what that tells us is that is an irrational solution. So the only time you're going to have 2 real rational solutions is when you have a positive number that is also a square number. Think 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, right? You know the list goes on and on. So you want to make sure you know those square numbers to look out for it, and because those are easy to take the square root of. 45 cannot be. However, I can simplify that, right? Now, when I go ahead and plug this in, that's nice. I can now just replace this with just a 45. All right, now these negatives get tricky. They get really tricky for a lot of students. So what I'm going to do is I'm just going to go really, really slow. But I am going to do a little sidebar math and say the square root of 45, that can be simplified. Right? I can rewrite 45 as a 9 times 5. I can take the square root of 9, so therefore it's going to be 3 times the square root of 5. All right? Then what I'm going to do is I'm simply going to break this up. See how this is -5 plus or minus square root of 45? That means we're going to have our 2 real irrational solutions. So I'm going to write them out separately and then simplify. Okay, now we can't really simplify anything further, but I do want to show you an alternative way to be able to write this solution. So therefore, if you were taking like a test or a multiple choice test, you would see, oh, my answer could be written like this. Like that's perfectly fine. Your teacher should accept that. But sometimes you might see the answer written in an alternative way. So I think this is really, really important to know. And this happens all the time on multiple choice tests. Students do the math right. They get the right answer. They know what they're doing, but the answer is not written in the format the way that they solved it, and they choose the wrong answer. So all we need to do to be able to change this, to write it into a different format, is to divide this -2 into both of our terms. Now notice a negative divided negative is now a positive, right? And again, this -2 doesn't evenly divide into either one of those, so therefore we're going to have some fractions, but it's going to look like this. So there you go. There are our two real irrational solutions. Hopefully this video was helpful for you. And if you want more help with solving using the quadratic formula or just solving quadratics in general, then check out the next video I have for you here. Cheers.